Hi guys. I'm live. Fortunately or unfortunately, uh, it's math lesson time. This comes up for me once in a while where I have some things I want to show you guys about math. And SHIRTLESSGUY here. Here's my chalk stencil board. I have 3 different ideas I'd like to go over. It might take me a while. So let's just jump right in. And first, a note to David Lee Roth. I really am going to not focus on my haters, like you said too, because I just unblocked Lina Ruiz and Amy dumped me for Amy dumped JRW for me. I'm his crime by Andy McKnight's channel. I just unblocked them. Whatever, they can do their thing. And that's also a testament that I'm not intimidated by either one of you, and I don't think that you guys are that high quality of people, and I have no reason to fear you. In fact, I can almost I don't know. I can almost feel sorry for you, but whatever. I won't go. That's not what this video is. This is math time. Okay. So I have 3 different things I want to talk about in math. First, I want to talk about this one I did not plan ahead by working it out. I haven't done this work in a long time. So I'm putting myself on the line by doing this live because I didn't work it out ahead of time to make sure I know what I'm doing. But I know I've done it before, so I know I can do it. I just in my past, and I'm not sure how it's going to work out. But rather than work it out and make sure I knew what I was doing, I'm just going to go wing it like I do. SHIRTLESSGUY, that's kind of my thing. So I'm going to talk about something called the golden ratio. First, there's 3 topics in this video. Golden ratio. If I can write this good. It's called phi. It's a Greek letter. This is the Greek letter phi, and it stands in math for the golden ratio. I do know the Greek alphabet from front to start. It's alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. And one of those is phi. And the golden ratio, let's just make it simple here if we can. Let's say you have this line here, this segment, and I make a line right here about. And what the golden ratio is, I want the ratio of this largest side, the whole ratio of that to the second largest portion, to be equal to the ratio of the second largest portion to the smallest portion. So in other words, the whole divided by the larger portion is equal to the larger portion divided by the smaller portion. It's called the golden ratio. And before I go into doing some math with that, well, let me do the math first. If I want to talk about philosophy and metaphysics, I'll talk later. So let's call the biggest one. Let's call this A. There's this larger section, and let's call the smaller section B, and that would mean that the whole section is A plus B. If I can even write. And what I'm defining the golden ratio as is that phi equals the ratio of the whole, which is A plus B, divided by the larger, which is A, which equals A, the larger portion, divided by B, the smallest portion. So that's the math of it, and I want phi to be equal to this, and let's see how I can derive this, because I haven't done this in a while. How do I derive it? So let's erase this up here. See, if I tank at this, it's right here on live, because I didn't go over this. I didn't plan out. I just know I've done this work before. Okay, so that's what phi is. Now, how would I derive that? How would I work with that? We can cross multiply, which really is a very juvenile term for multiplying extreme means and extremes. A plus B times B. So I'm going to write B times A plus B. That's this equals A squared. So we have that much to go on. Now, how did I work this out before? Maybe I'm missing something. Okay, let's do it like this. Okay, that wasn't useless, but let me try it like this instead. Let me do it like this. I'm gonna get creative here. I'm gonna start with the same line I did before, and I'm gonna take this. I'm gonna take this as 1, and then this big part as wait, dude, maybe I'm gonna blow this. How did I figure this out? That's 1, A plus B. Okay. Let's say that I know this is possible to do. If I say, gosh, dang, A plus A plus B, A plus B, B plus A. Here, let's rewrite what I just had and see if I can work with this. So we had that A plus B over A equals A over B. And that phi, okay, and then we have A B times A plus B equals A squared. And that means that B A plus B squared equals A squared. So we have that, A squared. And we have that phi equals A divided by B. Dude, I'm missing something. How did I derive what phi was? A squared equals A BA plus B squared equals A squared. B squared equals A squared. Oh, I can do this. I know. I'm going to sit here until I get this. So you might get interesting to see if I'm going to blow this because I didn't rehearse this. I just know I used to know this. That's the whole length. Okay, that's the whole length. And the ratio of that to the larger length is equal to the larger length over the smaller length. If this length is phi, and then this length is 1, right, guys? Then the whole length is phi plus 1. And the ratio of the whole length to phi, the larger length, equals the ratio of phi to the shorter length, which is 1. Oh, okay. Yeah, that's how you might do it. So then you work this out. You got phi plus 1. I'm going to cross multiply. Phi plus 1 equals phi squared. All right, there's that. And so hopefully you're following this because I think this time I did it right. I did not plan this. I did not make sure I was going to succeed at this. I just went with it. So phi squared minus phi minus 1 equals 0. So that's just putting the phi and the 1 on the other side of the equation. All right, that looks good. That was fun to be in the thrill of the moment. And now I think I have it, which is less fun for some dumb reason. The quadratic formula is that for a squared plus b squared. No, come on. I think it's like this. I think it's a. The quadratic formula, negative b plus okay, is that a for a squared plus b plus. Oh, okay. Quadratic formula. Yeah, the quadratic formula. Oh gosh, what's the quadratic formula? How does it work here? Is that what to do? Okay. Oh, okay. The quadratic formula is a x squared plus bx plus c equals 0, and it's x equals negative b plus or minus the square root of 4ac minus 2 4ac minus b squared over 2ac. I think that's it. Negative b plus minus square root. Negative b plus or minus square root of b squared minus 4ac. I'm just winging this. B squared minus 4ac. I think that's the quadratic formula. I'm just going by hard memory. Over 2a, not 2ac. Negative b plus minus the square root of b squared minus 4ac all over 2a. I think that's the quadratic formula. And if x then is phi, then the way to discover what phi is to plug it into this formula. Yeah, okay. Now, here a is 1, a equals 1, b equals negative 1, and c equals negative 1. So far, so good. B squared negative b plus or minus square root of 4, b squared minus 4ac over negative b plus or minus square root of b squared minus 4ac all over 2. I hope that's the right formula. Okay, that'll tell us what it is. So let's do minus square root of b squared minus 4ac over 2a. So two roots of it, and one's plus, one's minus. So that would be phi, because phi is x here, equals negative b, which is 1, plus or minus the square root of b squared, which is 1 minus 4 times ac is negative 1 all over 2a, which is 2. Fair enough? All right. And if I would have looked this up ahead of time, I would have ripped through this, but I didn't do that. I just kind of wung it with you guys. That's just kind of my thing. All right. So we have phi equals 1 plus or minus the square root of 1 plus 4, because negative 4 times 1, 4 times negative 1 is negative 4, but negative 4 is positive 4, so it's 1 plus 4 all over 2. Just hope I'm doing this right. Phi equals 1 plus or minus the square root of 5, because 1 plus 4 is 5, all over 2. Hope I did that right. Let me write that plus or minus better. Plus or minus. Now I'm getting that feeling that, can I finish this? All over 2. Huh. All right. Oh, okay. So phi equals square root of 5 plus 1 over 2. Or it could be minus 1. Is that correct? I probably should have square root of 5. Square root of 5 plus 1 over 2. Square root of 5. B squared minus 4ac over 2a negative b plus 1 square root of 4a negative b squared minus 4ac over 2a. All right, that's phi. I think that's correct. And that would mean that, oh, okay, I can deal with this. Oh, gosh. Phi equals, I think that's correct. I think that's correct. I think the math is good there. And then you just work out what that is. Square root of 5 plus 1 divided by 2. That's what phi is. Now let's check some things. And that's workable on the calculator. You just work that out on the calculator. It turns out that phi is an irrational constant, but it's equal to 1.618, and it goes on and on forever. I think that's interesting because there's a 6 and 18 is 6 plus 6 plus 6. So there's 4 6s in that alone. It's kind of like my birthday a little bit, but I won't go on about that. Yeah, square root of 5 plus 1 over 2. That's phi. Okay, let's do some work with it. Let's do some like tricks with it. So I'm gonna write it up here. Phi equals square root of 5 plus 1 over 2. I may just do this only in this video because it's taking so long because I didn't plan this out. I just totally winged this. And that's approximately, the swiggle equals approximately 1.618. All right, fair enough. I think that looks good. Now, what's funny about it too, you can do little tests with it. Like, what if I have 1 over phi? What if I want to know what that is? Let's do that. Well, that would be equal to 2 over square root of 5 plus 1. That's 1 over phi. And let's figure out what that might be. Now, my math is rusty here, but I'm going to do this anyway. That would mean that 2 phi equals square root of 5 plus 1. Cross multiplying again. And I didn't get anywhere because that just means you're backward. Oh, okay. So watch this. I'm going to say, what is phi minus, that is phi. I did write phi, right? What is phi minus 1? Well, phi minus 1, phi minus 1 is, let me think here. Yeah, what's phi minus 1? 1 over phi is that. 2 phi equals, oh, no, let's not do that. Let's just keep going here. So that means that 2 phi minus 1 equals square root of 5. And that means that, oh gosh, how did I do this before? What was I doing? 2 phi equals plus 1. 1 over phi is 2, which means that 2 phi equals that would make phi. Oh, dude, maybe that's cool. If 1 over phi is this, what if I make x equals 1 over phi? And that would mean that if x is 1 over, yeah, let's do it like that. Let's do it like that. Let's try that. If x is 1 over phi, then x, because it's 1 over phi, x equals 1 over phi, then x equals 2 over square root of 5 plus 1. Yeah, that would work. 1 over phi, because it's a reciprocal. Okay, so far we have that. X is equal to that. So let's erase some of this. I'm really going on a limb here because I think this is kind of what I wanted to do, but I'm hoping it works out for me, this math here. I'm defining x equals 1 over phi. So x equals 2 over the square root of 5 plus 1. All right. And what was I trying to prove here? X equals 1 over phi. 5 plus 1, square root of 5 plus 1. And that means that x times square root of 5 plus 1 equals 2. I don't know if that gets me anything. X equals square root of 2. Let's do this. Let's do this. So that means that square root of 5x plus x, yeah, equals 2. All right, I'll buy that. Oh, God, this is hard. X plus 1, x, oh, dang. 1 over equals minus 1. 1 over phi, which is x. All right. Minus 1. Yeah. Okay, let's not do it that way. Okay, let's just say that now x equals 2 over square root of 5 plus 1. Square root of 5 plus 1 over 2. Square root of 5 plus 1. Okay, there's that. And how did I work on that? And that means that x equals 2. That doesn't help. I'm trying to do this work here. X equals 1 over phi. X equals 1 over phi. I want to prove one little thing here. If phi equals square root of 5 plus 1 over 2, and I want 1 over phi. Oh, let's just do this. Let's do phi minus 1. Let's do that. And then let's try that. Phi minus 1 equals square root of 5 plus 1 over 2 minus 1. And let's call x, let's call x x phi minus 1. So that would mean x equals phi minus 1. Okay. Therefore, that would mean that x equals square root of 5 plus 1 over 2 minus 1. And that's phi minus 1. Yeah, okay, that makes sense. And the question is that equal to 1 over phi? So in other words, is that equal to x minus 1? Is that equal, is as if x is also 1 over phi, does that work too? So what I want to show, I want to just prove this one last thing here. It's taking a long time. I want to prove that 1 over phi equals phi minus 1. It's an unusual thing for a number to have that quality. When you subtract 1 from phi, phi is 1.61828. If you subtract 1, you get 6.618, which is equal to 1 over 1.618. Phi minus 1 is equal to 1 over phi. And I want to prove that. So let's see if I can do that in the time of this video. 1 over phi equals phi minus 1, question mark. Is that true? Question mark. I could say that. Let's see. 1 over phi is square root of 5 plus 1 under 2, not over 2. Because 2 over, yeah. Square root of 5 plus 1 over 2, that's 1 over phi. But phi minus 1 is square root of 5 plus 1 over 2 minus 1. There. If I can prove that's true, then 1 over phi equals phi minus 1, and that's very unique. It's the only number that has that quality, I think, in all of math. And that would be if 1 over phi is 2 over square root of 5 plus 1. Phi minus 1 is square root of 5 plus 1 over 2 minus 1. If that is true, then 1 over phi equals phi minus 1, and that's the last thing. Then I'm done with this video, because I'll do the other things later. All right, let's see if that's true. Dude. Okay, so I have 2 over square root of 5 plus 1, and then I'm going to talk about the metaphysics of this, equals square root of 5 plus 1 over 2 minus 2 over 2, because 1 is 2 over 2. So I have 2 over square root of 5 plus 1 equals square root of 5 plus 1 minus 2 over 2. Okay, let's see. Let's see if that's true. Okay, see if that's true. Does that work out to be true? I hope it does, because that would make me correct in this, which would be nice. So I'm going to see, is this true? Is 2 over square root of 5 plus 1 equal, question mark, square root of 5 plus 1 over 2 minus 2. Like that, right? That makes sense? And is that true? So that would mean that, I'm going to erase this down here because I wrote it up there already. 2 over square root of 5 plus 1 equals, question mark, square root of, that's an awful looking square root of 5 there. That's supposed to be square root of 5, and I can't even tell what that is. Square root of 5. But square root of 5 plus 2 minus 2 is square root of 5 minus 1 over 2. So is that true? I sure hope it is. Let's cross multiply. 2 times 2 is 4. Square root of 5 plus 1 times square root of 5 minus 1. Let's see if that's actually true. It would do me a great service if it were. So in math, if A plus B, how's that go? Times C plus D is first, which is AC, plus second, which is BD, first, second, plus inner, plus BC, plus the outer, AD. I think that's how it goes. Yeah, first, second, inner, outer, like FOIL. So let's use that in the calculation of this and see if this is true. So 4 equals, question mark, first is square root of 5 times square root of 5, which is 5. Second, 1 times minus 1 is minus 1. Inner, 1 times square root of 5 is plus square root of 5. Outer, square root of 5 minus 1 is minus square root of 5. I hope this works. So 4 equals question mark 5 plus minus 1, which is 5 minus 1, which is 4, and square root of 5 minus square root of 5 is 0. So 4 equals 4. So it is true. Jeez, man. So what I proved was, and I didn't even know that, I just won all that and it worked out. So that's a good thing. And I did it live, so if I hadn't messed it up, you guys would have seen the whole deal. So there's that. Phi is such that 1 over phi equals phi minus 1. Try to find another number that's true for. You'll have a hard time. That's kind of the definition of phi. In fact, let's work from there. I mean, this is one last thing. Before I philosophize a little bit. If 1 over phi equals phi minus 1, let's see what phi is. So let's see. Can I even do that? Let's multiply both sides by phi. Then I have phi equals phi minus 1 times phi. Multiplying both sides by phi, correct? Now you have phi equals phi squared minus phi. I'm not even writing phi right anymore. And that's minus, not plus. Minus phi, okay? Phi equals phi squared minus phi. All right. And then, and that's true though. Wait, let's see. Phi equals 1 multiply both sides. Oh yeah, phi squared. Yeah, okay. So to subtract phi from both sides, you have phi squared minus phi equals 0. Is that right? And then phi squared minus 2 phi equals 0? Equals 0. One over phi. Did I do that right? 1 over phi. Oh. Oh, multiply both sides by phi. Okay, that's correct. All right. Okay. I'm not sure if I'm doing this right. Minus phi equal. Let's just see if phi turns out to be what it should. And this would be the final thing. I hope I did this right. So I have phi squared minus 2 phi plus 0 equals 0. And let's see what that would be. Quadratic formula. That would be then in the quadratic formula, A equals 1, B equals -2, C equals 0. The formula is phi, or x, but it's phi this time, equals -b plus or minus square root of b squared minus 4ac all over 2a. It's a quadratic formula again. And let's see if that works out for those numbers. Jeez. Okay. So phi equals question mark. -b is 2 plus or minus the square root of b squared is 4 minus 4 times ac is 0. All over 2a. Which a over 2. Oh gosh, hope I didn't do that wrong. Yeah, that's I don't know if I'm doing this right. Right, what was I saying? Phi divided by 1 equals phi. No, not divided by 1. 1 over phi equals phi minus 1. All right, that's where I was. How do I do that mathematically? All right, so that means that phi minus 1 minus 1 over phi equals 0. Okay, fair enough. Now what do I do? I did that wrong. Now I'm going to do it right. Now I'm going to multiply the whole thing, both sides by phi. So that would mean, multiplying both sides by phi, that would mean phi squared minus phi minus 1 equals 0. Because phi times 0 is still 0. Phi times phi is phi squared. Phi times minus 1 is minus phi. Phi times 1 over phi is minus 1. Let's see what that is, and if that, by the quadratic formula, and see if it works to be true, to be equal to 0, right? B plus minus square C. So yeah. Or let's see what phi is. And if phi is what we know it is, then that would mean that the original assumption, 1 over phi equals phi minus 1, is true. So here we have it. This is the final thing. And then I'm going to philosophize a little bit. Minus 1 equals 0. I mean, not even, yeah, okay. So in the quadratic formula, A equals 1, B equals minus 1, C equals minus 1. Quadratic formula, phi, equals negative b plus or minus the square root of 4a. Then b plus the square root of b squared minus 4ac all over 2a. Okay, that's correct. So phi equals negative b, which is, b is negative 1, so negative b is 1, plus or minus the square root of b squared is, negative 1 squared is 1, minus 4 times a is 1 times c is negative 1, so that's times minus 1 all over 2a, but a is 1, so that's 2. Yeah, looks good. So that would mean that phi equals 1 plus or minus negative 4 times negative 1 is positive 4. So that's 1 plus or minus the square root of 1 plus 4 all over 2. And 1 plus the square. Yeah, so let's go back to the top here. Phi then equals 1 plus or minus square root of 1 plus 4, which is 5, all over 2. So that then does work. That does work. Since that is phi, because we already saw that phi equals square root of 5 plus 1 all over 2. Huh. Yeah. And that is phi. So that proves, one way or the other, hope I'm not in the way of the board all this time. That proves one way or the other that 1 over phi equals, a little better here. 1 over phi equals phi minus 1. That just proved it. And that, because that's phi squared 5 plus 1, so it worked out. So I did it. I did a few things. I proved, and all you got to do to figure out what phi is, put in your calculator square root of 5 plus 1 over 2. It's about approximately equal to 1.618. Then square root of 5 plus 1 over 2 minus 1 equals 1 over square root of 5 plus 1 over 2, which is 0.618, because it's 1.618 minus 1, which is then approximately equal to 0.618. So fair enough. I put my butt on the line there because I did this all, I just had the idea that I wanted to remember this, because I know I've done it, but I didn't plan it. I didn't redo it until I did it with you guys. So that's a little math. Now, I was going to philosophize a little. I want to do that. I think I want to philosophize some. Um, First of all, in the show Person of Interest, Finch says that when the machine gets erased at midnight, it reboots after 1.618 seconds, which I think is really interesting. He said that because that's the golden ratio. He didn't have to say that, but the people that wrote the show are smart and put that in there. Now, let me talk about the golden ratio for a second. I was studying in church, and some guy that's really smart told me. He said, Jimmie, phi is used in all nature. You know, all nature has phi. Plants, rabbits, bananas, you know, anything in nature is the beauty of it is based on how close its features resemble phi, the golden ratio. And it's all through nature. Spiral of a shellfish, starfish, dolphins. I mean, everything's beauty is basically how close you get to phi in your physical appearance. So if you're beautiful, then you're close to the golden ratio in your features. If you're not, then you're not as beautiful. It's very mathematical, actually. It can be even reduced to a computer program probably one day that could score your beauty based on a scientific scale. Where Candace Swanepoel is the most beautiful, maybe one of the most in the world, because her features are just like phi. She would have a very high score, and an average person would be lower. But the conversation didn't stop there. He said, Jimmie, what's the question? You know, try to answer this. What's the one feature in the universe that in life that doesn't have to match the golden ratio, that can vary the most from that? And I couldn't answer it. I was like, I don't know, dude. He goes, the human face. The human face is the most ugly thing in nature because it's the thing that can be varied most from phi. So when God, if he made us, creates someone, he can make their face. The face is the thing that is most has the most the less like phi possible. And nothing, you know, the human face can be very varied. It can be very not close to phi in its ratios, meaning basically the human face is the ugliest thing in the universe. But then he said something further. He said, but God, what's interesting about that is when God makes a beautiful face, he doesn't work that hard because he makes everything else beautiful too. He makes shells beautiful. He makes dogs beautiful. Everything's easy to make for God as long as he just has to spit out the golden ratio. So beautiful people are easy for God to make. The interesting thing is God has to work harder to make a face that is further from the golden ratio, which means that ugly people, God worked harder. He worked harder to make their face ugly because he had to make it specially that way. Whereas if he just turns one out like the golden ratio, and it's a beautiful face. So basically he inverts the idea of beauty, meaning that people with beautiful faces are easy for God to make, whereas ugly people take more work for God. I'm quoting it as he said it. I'm not trying to make a value judgment on it or say anything particular, but I think it's interesting. How about that, guys? You know, it's interesting. Beautiful people, easy. Ugly people, hard to do. Anyway, I love you guys. Peace, rock and roll.